Plot of angular wave function. 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 The angular wave function is independent of the radius. The angular wave function is independent of the radius. The wave function psi of s orbital do not change with angles because these are non-directional. The wave function psi of s orbital do not change. Psi of s orbital do not change with angles because these are non-directional, and all s orbital are spherical. Hence all s orbital are spherical. S orbital are spherical. Hence all s orbital are spherical. This is the z-axis, and this is the x-axis, and this is the y-axis for s orbital. All s orbital are spherical because the angular wave function is independent of the radius. The wave function psi of s orbital do not change with angles because these are non-directional. Hence all s orbital are spherical, symmetrical. Angular dependence of different orbitals have been shown. The position and negative sign as shown plus v minus v orbital wave in the particular region. When the angular part of the wave function is plotted, the following figures are obtained. For px, py and pz, for p orbital. For p orbital, x, z, for p orbital, py. This is the py. This is the py. And z-axis, y-axis, and x-axis. This is minus, this is plus. In the x-axis, so as minus, plus. And for z-axis, this is for px. For z-axis, as so as. For z-axis, for pz. This is the plus, this is the minus. Plus v, comma minus v, orbital wave in the particular region. Orbital positive sign and negative sign shows plus v and minus v orbital wave in the particular region. This is the for p orbital. Probability density. Probability density psi square. Square of psi or psi square. The orbital wave function psi has no physical significance. Hence, this There is no any importance for the graph plotted between psi psi square has physical significance. Psi square is the measure of probability of finding the electron in unit volume. Psi has no physical significance. Has no physical significance. Physical significance. Significance. Psi square is the measure of probability. Is the measure of probability. Measure of probability of finding the electron. Of finding the electron. Of finding the electron in a unit volume. In a unit volume. The graph between psi square and r shows probability density. The graph between psi square and r. Between psi square and r. The graph between psi square and r. Probability density. Probability density. Suppose we have to calculate the probability in small area, then we multiply psi square with area of the small region. Probability equal to psi square into dB. This is a small volume. This is the small region. Then psi square into 4 pi r square into dr. Then equal to 1 minute. Equal to 4 pi r square dr into psi square. That means radial probability. Radial probability equal to probability density. Probability density into volume of radial shell. Volume of radial shell. The radial probability is probability of finding the electron in a radial shell. If r is the radius of the sphere and r plus dr is the infinitesimally small charge in the radius, the volume dV of the spherical shell can be calculated. 4 pi square r. Radial probability distribution.